Hi there, welcome to our parents' kitchen. We've been asked if we can help them solve a problem. They just installed a new kitchen, a modern one without any knobs or handles to open the drawers. And this causes one big problem. The trash cans are hidden within this drawer. And it's kind of difficult to open since there's no handles. But another problem is that it's quite low. So whenever you have to come over and open it, you have to bend down, try to grab a hold and open it. And if you're carrying stuff you want to throw away, this causes a problem. So we got to come up with a hands-free solution to open this drawer.
We decided to use a servo to simply push the drawer open. This way you can still open and close the drawer as usual. But if you need, you can have the servo open it for you. We guesstimated that a 25 kilo servo would do the job. To have the servo push the drawer far enough open, we needed to add an extension arm to the servo. The downside to adding an arm like this is that the servo becomes less powerful. Additionally, we added a ball bearing at the end of the arm to decrease the wear and scratching on the drawer. Now, with the servo in place, we had to figure out a way to interact with the servo to make the drawer open. We looked at voice commands like Google or Siri, physical buttons, vibration sensors, so you can tap on the doors, or optical sensors, which needed a swipe with your feet underneath. After a bit of tinkering, we settled on the swiping motion with your feet. It's easy, it's quiet, and it's convenient.
We're using an Arduino Nano. Since the trash cans in the kitchen are in frequent use, this setup will not be battery powered. Start by connecting the Arduino to your computer and upload a sketch. There's a link to the sketch in the description. Then hook up the obstacle avoidance sensors to VCC and ground. Connect the out pin of sensor 1 to pin D5 on the Arduino. And connect the out pin of sensor 2 to the D4 pin. The servo requires more power than the Arduino pins can deliver. So first, hook up ground of the servo to common grounds with the Arduino. Then we're going to connect VCC of the servo to a 5-volt power supply. This is the same power supply we use to power the Arduino. Connect the input pin of the servo to D3 on the Arduino. And finally, we're using a buzzer for audible feedback. Connect the positive terminal of the buzzer to D10 and a negative terminal to ground. That's all the wiring. You'll find a link to all the parts in the description.
To house the servo and the Arduino, we built our own custom box using a CNC. This way we can customize the box as we like. You can of course build one without a CNC and just use a standard project box. Just make sure that the servo is well secured so it will not pop out, and use a project box that can be screwed in place.
To detect the foot, we're going to use 2 infrared obstacle avoidance sensors. They're easy to use and you can adjust the sensitivity to fit your setup. If the sensors are picking up signals too easy, you can just add a divider between the LED and the receiver. The idea is that you swipe your foot under the 2 sensors installed under the kitchen cabinets in less than 1 second. We installed them about 20 centimeters or about 8 inches apart. The reason for using 2 sensors instead of just 1 is to avoid accidental opens. We're going to use an Arduino Nano for handling the sensors and starting the servo, but more on that later on.
To prototype our build, we decided to mount it in Mike's kitchen. To figure out how far back we should mount the device, we simply lay it down and close the drawer. Then it will be pushed back to the perfect location. Then we just screw it down to the floor of the cabinet. The wires for the sensors are pulled under the drawer and attached under the cabinet as described previously.
We're mounting the Arduino on a perf board and using pin headers so we can easily pop in and out the Arduino. You can of course Solder everything to the Arduino if you prefer. Twist the wires so that you can easily handle them when installing the device. Note that the Arduino cannot power the servo when connected to your computer. Hook up the completed device to a 5-volt power supply and make sure everything works as expected.
And then the moment of truth. It works, kinda, but we ain't there yet.
The problem is that the servo is just not strong enough to push the drawer as far as we like to. So we can either increase the power by changing the servo, or we can decrease the friction, making it easier for the drawer to just slide out. This door is fitted with an automatic soft close device. When the drawer goes out, it pulls the hook along, but when it comes back to close, the drawer is snapped on and slowly pulled back into its place. This device adds a lot of friction to the equation. While removing one of these and leaving one in place, the drawer still maintains its auto-close feature, but it now has a lot less friction.
Let's see if the problem has been solved. Success!